Hello class, good day. I hope you are all well. Welcome to our fifth lecture. Today we will talk about structural steel. Well, supposed to be dapat ito yung nauna, no? Pero nauna na nating na-discuss ang mga reinforced concrete. But now we will talk about structural steel as a whole. As the sole strength provider for our structure. So, mga structures na gawa mismo sa bakal. So, imagine niyo no? Si unang-una diyan, si Eiffel Tower, mga steel bridges, mga golden bridge, 'di ba? Those are made up primarily of structural steel as their reinforcement. So, our outline for today, brief summary, the history of steel, advantages and disadvantages, and the steel sections. So, kung before we talk about rebars, reinforcements, meron siyang mga sections, pwede mo siyang iba't ibang gawing section, meron din sa steel. So, introduction. So, steel has become the predominant material for the construction of, as we said earlier, bridges, buildings, towers, and other structures. So, a combination, an alloy of iron and carbon. And sometimes other elements such as nickel in order for it to be, to avoid rust sa mga stainless steel. Sa mga, ano bang sample ng stainless steel? Yung mga roofings, di ba? Mga floorings. Carbon content varies from 0.1% to not more than of 1.7%. And iron with less carbon and iron with higher carbon content as components of your steel. So some applications, your bridges, museums and buildings, high-rise and low-rise. Your towers, so the Eiffel Tower, mga transmissions line. Yan. Early history of iron and steel. Metal as structural material began with cast iron. So, mga bridges din, from the 1700s to the early 1840s to the 1800s. So, puro bridges ang application. So, we can realize here that steel, we maximize the use of steel sa mga bridges. In 1855, development of Bessemer process for large quantities and at cheaper prices. And in 1900s, 1989, different shapes. So, advantages and disadvantages of steel. So, the same as your reinforced concrete or reinforcing steel. Almost the same properties. High strength, steel per unit weight. So, you have also your variation in strength per length. No? This means dead load will be small. Uniformity, it's also monolithic. Properties of steel do not change appreciably with time as to reinforced concrete structures. Elastic and ductile, so it can be bended, it can be bent. So, meron tong actual formula from the Hooke's law, but we'll be further discussing your mechanics of materials. So, it gives warning before failure takes place. Meron munang cracking na magaganap before actual failure occurs. Disadvantages of using steel: maintenance costs, so high exposure to weather conditions such as air, water, and humidity. Must be painted periodically in order for you to avoid rust and other chemical reactions. Fireproofing cost, so steel is incombustible material but the strength is reduced tremendously at high temperatures. Kaya pala, na kapag nasusunog ang isang bahay, prone siya sa failure, di ba? Pwede siyang bumagsak pag hindi maganda ang mga steel material na ginamit. Susceptibility to buckling, ito yung mga nangyayari sa mga bridges, sa mga malalaking mga columns, pag hindi niya kaya yung dead load niya. Hindi niya kaya yung load na dinadala, nagbe-break yung mga columns. Fatigue, the strength of structural steel member can be reduced if the member is subjected to cyclic loading and brittle fracture. May loses ductility and brittle fracture may occur at places of stress concentration. So, pag concentrated, same thing with the columns, concentrated sa midpoint or sa buong area ang iyong weight or yung dead load, probability for fracture and buckling and other types of failure. So, fireproofing, you use different types of board, in this case, gypsum board, no? Or spraying for, sprayed on for fireproofing. So, sample illustration for your fire protection. So, stress range for your cycles of fracture. So, this class will also be discussing your mechanics of materials. So, meaning lang nito that as we increase the load, okay, syempre, di ba, the stress is parallel to your, proportional to your force. So, cycles of fracture in the 10 to the 6 Newton. So, meaning na kayang i-withhold with maximum stress ang mga structural steel rod. Fatigue lamination, when still more than 2 or 3 inches, thick is used in beams of very long bridges of very high buildings. So, steel is fatigued by reversal of stress from tension to compression and vice versa when it's repeated many times. So, may fatigue results to failure of your structure. So, reversal of stresses. And steel sections, so the most common are the following: I-beam, T-beam, and C-channels. So, these are your proper cross sections. I section, H section, channel section, and your angle sections. So, aside from this lecture class, typical applications muna. Column, corbel, beam, brackets, framing, and your trusses. Your truss systems, I hope we have encountered this in your statics and further on in your mechanics and matrix analysis. So, yan, application yan. And for your steel design, of course. So, for your cold formation, cold rolled steel is manufactured at temperatures below its recrystallization temperature, typically at around room temperature. So, samples. So, for small scale, no? So, partitions, flooring system. Pero same din for framing, for roofing, and so on and so forth. So, under this link, or in this video class, I'll be inputting also some videos for us to watch. How do you create, how steel is formed, and yung hot formation and cold rolling. And so, I hope you learned something. So, this very short lecture for structural steel. Thank you and God bless, class.